Hello and welcome to the first video. Today we're going to be looking at calculations, very simple calculations. First of all, we're going to look at how to calculate the relative formula mass or the relative molecular mass, depending on whether it's an ionic compound or a molecule. And secondly, we're going to look at the percentage mass of an element in a compound. Right, first of all, we need to, what is it relative to? We need to sort of answer this question. Now, the element symbol has two numbers attached to it. Now, the smaller number and the larger number. So aluminium is 2713. Now, the relative mass of the aluminium atom is 27. Now, what that means is it is 27 times heavier than a hydrogen atom. Bromine is 80 times heavier than a hydrogen. So the mass of a bromine atom, one bromine atom, equals the mass of one hydrogen atom. Actually, that's not entirely true. This little relative, it's actually relative to carbon-12. And it's relative to actually 1/12 the mass of a carbon-12 atom. So it defines carbon-12 as exactly having a mass of 12. So hydrogen is 1 times 1/12 the mass of carbon-12. Or a calcium atom is half the mass of a bromine atom. Or a magnesium atom is 24 times the mass of 1/12 the mass of a carbon-12 atom. That's how it's technically defined. But you just use the larger number in the symbol on the periodic table. That gives you the relative mass of the atom. So we're going to look at a couple of examples of calculating the relative formula mass or the relative molecular mass. So if first of all we look at calcium oxide, the mass of calcium oxide. So we've got two atoms there, one calcium atom, one oxygen atom. The calcium atom has a mass of 40, so it's going to be 40 plus the mass of the oxygen atom. If we have a look down, the oxygen atom has a mass of 16. So the relative formula mass for calcium oxide is going to be equal to 56. Okay, and because it's a relative mass, it doesn't have a unit. Okay, let's look at another example. Let's look at ammonium sulfate. So ammonium sulfate is NH4 to SO4. Okay, it's a little bit more complicated. Now, these brackets mean that you have this number of things inside the bracket. So we have two ammonium ions, so we have two lots of NH4, and one sulfur and 4 oxygens. Okay, so one way to add this up is to work out the mass inside the bracket. So the mass inside the bracket is 1 nitrogen and 4 hydrogens. So nitrogen is 14 and hydrogen is 1. So that's going to be 14 plus 4 lots of hydrogen. Okay, so the total inside the bracket is going to be 18. But we have 2 ammoniums. So we're going to need to multiply 18 by 2. So the total inside is going to be, so that's 18, and we need to multiply that by 2. So the total inside the bracket is going to be 36. Now, we still need to add up the sulfur and the oxygen. So sulfur has a mass of 32, and oxygen has a mass of 16. So this is going to be, we need to add 32, and then we also need to add, we have 4 atoms with a mass of 16. So, and if we add all that up, it should equal 132. So 2 lots of the ammonium ion, so 14 plus 4 times 2 plus 32 plus 4 times 16, because we have 4 oxygens. The other way to do it is to say, well, we have 2 nitrogens, because this 2 applies to everything inside the bracket. So we have 2 nitrogens, and we have a total of 8 hydrogens plus 8 hydrogens plus 32 plus 4 lots of oxygen, and that will give us the same number. It doesn't matter. Both ways to do it are absolutely fine. Okay, so now we can work out the relative formula mass of a compound. We can look at the percentage mass of an element in a compound. So, for example, if we looked at the percentage of oxygen in sodium carbonate. Now, what we need to do is you need to add up the mass of all of the atoms of the element and then divide by the total mass of the MR. So here we have the mass of oxygen, and that has to be all the atoms divided by the MR. Okay, oh, times 100, because it's a percentage. Okay, so we have, in sodium carbonate, we have 3 oxygens, so that's going to be 3 lots of 16, okay, and that's going to be 48, divided by the MR of sodium carbonate, which is 23, 2 lots of 23, plus 12, plus 3 lots of 16. So that's going to be 48 divided by, that will add up to 106. So 48 divided by 106 times 100. So 48 divided by 106 times 100 is 45%. So the percentage of oxygen in sodium carbonate is 45%. Okay, have a go with the questions here, and I'll come back and go through each and every one of them in the second half of this video. So you might want to pause the video, attempt the questions, and then we'll go through them.